All right, well, we're moving on here. In general, a convention, so that's kind of like a rule, a pattern that we typically do. A convention is that we write it in descending orders, descending powers of x. So the order is whatever the exponents are, we're going to go in descending order, but only for the x. So you see the x3, then the x2, then the x1. Here, the x3, the x2, the x1, and then no x's at all. So that's what the convention is. And so it says here we would like to rewrite it in order. And you have to be really careful here. So this is the 5x squared. That's the first one. That's a positive 5x squared. So I'm just going to write 5x squared. When you start something, if it's positive, you don't need to write the positive. Then there's a 2x. It's not negative, it's positive. And then there's an 8 that's negative. So we've got an x squared, x to the 1, and then no x. So that is rewritten in descending order. Here, you've got an x cubed, but if you look in front, it's a negative, so it's a negative x cubed. Then you've got an x squared, and it's a positive 5, so a positive 5x squared. And then we have a 2x, and it's positive, so we're going to do a positive 2x. Notice there's no plus sign there, but that's because that's the beginning. Here it's at the end, so I had to put the plus sign. Moving on. The x cubed, that is the highest exponent, so that'll come first. Then the x squared, it's a positive 5x squared, so I'll put positive 5x squared. Then just the minus 8 with no x's at all. So that is in descending order. Now we'll do, it says positive x cubed, that's the highest exponent. So that's what we'll do first. I don't need to put a positive sign because it's at the beginning. Then a positive 5x squared. Then a positive 2x, doesn't say positive, but it is. And then a minus 8. So that is us just rewriting in descending order. And so when we answer the question, like there's not going to be a question that's really like this. However, we're going to be multiplying and adding and subtracting. And once we do all that, we want to make sure our answer is in descending order. Now let's talk about collecting like terms. So collecting terms, you should know what a term is. They're separated by a plus or a minus. So there's two terms example right there. So we're going to collect terms that are alike. And if we rewrite the variables in alphabetical order, that helps us a little bit in seeing which ones are alike and which ones are not. If they are exactly alike, then we can add them. So for instance, down here you've got 5x plus 4x. They both have just a single x, so we can add them. It's 9x. 5 plus 4 is 9, and they both had the same x, the same variable. So in this one, you've got an x squared y cubed in that term, and in this term, you have an x squared y cubed. They're identical. The exponents are identical on the letters. So because of that, I can go 12 minus 4 is 8, and then we just have the x squared y cubed. That is the common, that is the terms that are alike. So you have to keep them like that. So you don't go x squared plus x squared is x4, and x3 and x3 is y3 and y3 is y6 or something weird. No, just leave it at whatever the terms were that were alike, and then you can just do the coefficients, which is the 12 minus the 4. It says, but 12 minus 4, and then there's an x squared y cubed and an x cubed y squared. So, I mean, look at it. There's a 2 and a 3, a 2 and a 3. There's x's, there's y's. It looks identical, but it's not because there's an x squared and an x cubed. So it has to be exactly the same. So we cannot add these. These are not alike. So the answer to this is just to rewrite it. There's literally nothing we can do. We cannot add them. So the only thing is just to say, well, let's leave them separated. And so we're going to be trying to find which terms are alike, and then we can add the ones that are alike or subtract the ones that are alike. And anything that's not alike, well, we just leave it separated. So let's take a look at the first one here. It says reorder the variables and then write them in descending order and combine like terms. So this is an x, y, z. That's perfect. That's already alphabetical. this is a yzx, so let's rewrite that as the x first, then the y, then the z. And then minus, again, these are out of order, so we can write the x, then the y, then the z. And the numbers are, you don't see it here, but there's actually a 1, and a 1, and a 1. So the coefficients, if they're not written, are 1. So this is alike with this and this. They are all alike. So we can combine them. 1 plus 1 is 2. 2 minus the 1 is 1. So you have a 1, and then you just have the variables, x, y, z. So I rewrote them, double-checked. You can see I've kind of underlined the ones that are alike. They were all of them. And then I combined them. So hopefully this is not, we'll see here. Hopefully this is not all the same. So we have to write, there's an x squared. So we got to write the x's first, x squared, then the y, then the z, minus 8. And then you've got x squared again, then the y, lastly the z, plus the 5. Okay, so the x is there. Then we have a y squared. Already that's different than the other ones. And then a single z. Minus, I'm going to write a 1 because there is a 1 here. There's an x, then a y squared, and then a z. So I rewrote them all alphabetically, making sure to keep the exponents with the right variables, the right letters. And then I have to write down, and I like to usually indicate to whoever's reading this which ones are alike. So x squared yz is the same as this, x squared yz. Now this one is x y squared z, but it matches this x y squared z. So these ones are alike. So I can take these. 2 minus 8 is a negative 6. And then I can write down the variables, x y squared z, so I can combine them. 2 minus 8 is minus 6. And then I write the variables, x squared y z. And these are the same. 5 minus 1 is a positive 4, so I'll put a positive 4. And then I have to write down the variable, x y squared z. So we have taken something, we reordered it, and then we combined like terms. And there's one more. It's going to require some serious reordering here. So there's an x squared, then a single y, and then a z squared. Minus 8, an x squared, y squared, single z. X squared, y squared, single z. Already those are different. Plus a 5, x squared, then a y squared, and then a z. Minus an x, and then a y squared, and a z squared. And I'm going to write a 1 down. So I have to really pay attention here and make sure which ones are alike. So there's this one, x squared y squared z, and this one, x squared y squared z. Now, does this match this? X squared, x1, so no. So the only things that are alike are these ones. So I'll write this down here, 2x squared y z squared. That didn't have anybody to combine with, so I just brought it down. Negative 8 and positive 5 is negative 3. And then we've got the x squared y squared z. So those combined there. And then this will have to get carried down. Minus 1 x y squared z squared. And so you notice it goes, there's 3, so it went from 4 things here to 3 things where we combined it, but we also reordered it. And it has an x squared, and then this one has an x squared, and this one has a single x. So it actually is in descending order. So that is my final question, or my final simplification. Remember, these are expressions. These are not equations. We're not finding out what x equals. So I will zoom there for you to copy that. And we will do example 2, which I think is very much the same.